Ready to explore the mysteries of time travel? Welcome to our channel. This episode, we talk about Albert Einstein's theory of relativity, explaining time travel. Albert Einstein's theory of relativity is one of the most famous and influential scientific theories of all time. In addition to providing a new understanding of the nature of space and time, it has also introduced the idea of time travel into popular culture. In this video, we will explore the basics of Einstein's theory of relativity and how it relates to the concept of time travel. To understand the theory of relativity, we first need to understand the concept of space and time. Before Einstein, it was generally believed that space and time were separate and distinct entities. However, Einstein proposed that space and time are actually interwoven into a single entity known as spacetime. This concept is crucial to understanding his theory of relativity. Einstein's theory of relativity is actually split into two parts: special relativity and general relativity. Special relativity deals with the relationship between space and time in the absence of gravity, whereas general relativity extends this relationship to include the effects of gravity. One of the most famous implications of Einstein's theory of relativity is the idea that time is not absolute. Instead, time is relative to the observer's frame of reference. This means that time can appear to pass more slowly or quickly depending on the observer's motion and the strength of gravity at their location. The theory of relativity has been confirmed by numerous experiments and observations over the years. For example, the famous Michelson-Morley experiment of 1887 showed that the speed of light is the same for all observers, regardless of their motion. This is a fundamental principle of special relativity, which states that the laws of physics are the same for all observers moving at constant velocity relative to one another. Like and subscribe. So what does all of this have to do with time travel? The concept of time travel is actually closely related to the idea of time dilation, which is a consequence of special relativity. Time dilation refers to the fact that time appears to pass more slowly for objects that are moving relative to an observer. Imagine you are on a spaceship traveling at a significant fraction of the speed of light. From your perspective, time appears to pass normally. However, from the perspective of an observer on Earth, time on your spaceship appears to slow down. This means that if you were to return to Earth after a long journey, you would have aged less than the people who remained on Earth. This effect has been confirmed by experiments using atomic clocks on airplanes and satellites. The clocks on airplanes and satellites appear to run slightly slower than clocks on the ground, due to the fact that they are moving relative to the observer on Earth. But what about traveling back in time? Is it possible to use time dilation to travel back in time? Unfortunately, the answer is no. While time dilation does allow for objects to experience time at different rates, it does not allow for time travel in the traditional sense. However, there are some theories that suggest that time travel may be possible in other ways. For example, some physicists have proposed the idea of wormholes, which are hypothetical shortcuts through spacetime that could potentially allow for time travel. However, existence of wormholes is purely theoretical at this point, and there is no experimental evidence to support their existence. Another concept related to time travel is the idea of closed time-like curves, which are paths through spacetime that loop back on themselves. While these paths are allowed by the equations of general relativity, it is not clear whether they could actually exist in the real world. Additionally, if closed time-like curves do exist, they could potentially lead to paradoxes such as the grandfather paradox, in which a time traveler goes back in time and accidentally prevents their own existence. In conclusion, Einstein's theory of relativity has provided a new understanding of the relationship between space and time. While it has opened the nature of time and the universe. As our understanding of the universe continues to evolve, who knows what other secrets of time travel may be unlocked in the future. Thank you for watching.